All right, hi everyone. We're looking at our next topic in the transformations unit. This time we're looking at rotational symmetry. Now, specifically, rotational symmetry is a type of transformation that turns a figure onto itself by some angle between 0 and 360 degrees. And we are going to be turning these about the center of the figure. So specifically with rotational symmetry, we have what's called the order, which is the number of times. Sorry, let me rewrite that, which is the number of times a figure can be turned on itself. Okay, that is the number of times a figure can be turned onto itself. Now, with that order also comes magnitude. Specifically, magnitude is the angle of one of those single rotations of the figure. So we have a rule to help us find the magnitude. And that is to take the 360 degrees that it takes to go all the way around back to where you started, divided by your order. So let's check out example 1 and see how this rule for magnitude is going to come in. All right, so we have a figure down here. We have this triangle and it's divided into 3 sections. So if we start at that top point there and we turn it to the right or to the left, for order and magnitude, it doesn't matter which direction you go. But if I go to the right for my first turn, I'm in the bottom right corner. So right now I've gone 1 turn, and it still looks like that same triangle shape. I can turn it a second time, and I still have the same triangle shape. And then the third time, I'm back to where I started, which means this has an order of 3. Now we'll use that 3 to get the magnitude. So again, 360 degrees divided by my order, which means for every one of these individual turns, I have rotated 120 degrees. So we're going to use that to figure out how many turns can we get out of a certain number of degrees here. So if 120 was one single turn, and I need to now rotate this figure 120 degrees clockwise, the 120 tells me 1 turn. Clockwise means we will turn to the right. So this is going to be 1 turn. Now, those pictures that are inside each of these spaces are there for a reason. They're very specific because as that triangle turns, as we turn it to the right, those little figures turn with the shape. So let's go back to that triangle for a second. Let me erase our turns that we did. And we'll see what happens and actually turn this and see how those shapes will rotate with us. So let's get this original one up here. And there's our dividing spaces. All right, so let's get this over here so we can see it. Oops. Undo. All right, so as this triangle is turning, we can see how the smiley face, the heart, and the triangle rotate as well. And as this turns to the right, 1 whole turn, now I can see that my smiley face has the eyes pointing to the bottom left. My heart here it comes. My heart will be in the bottom left corner. And then that just leaves us with the star, which would be in the top space. So again, it rotates as it's going along, and those pictures have to rotate as well. All right, so now let's check out the next one. Let me erase part of this rotating triangle here so it's not quite in the way. And let's look at example 2. So this time we have a pentagon here, 5 sections to it. And if we did the same rotations, whoops, I've still got a triangle popping in there. So now when I rotate this one, I get 5 total turns. I get 5 total turns. So now I get 5 total turns. So my order is 5. 360 degrees divided by that 5 means I have 72 degrees for one rotation. Oops, still got a little bit of a triangle rotating up there. All right, so let's use that now and figure out how many turns we're going to get out of our degrees. This time we've got 144 counterclockwise turn, 144 degrees counterclockwise. So we need to see out of 144, how many 72-degree turns are we going to get out of that? And that is 2. So 2 turns counterclockwise to the left. So let's see what we get this time. So now the 2 figures that we have at the top, the plus and the heart, our plus will now move 2 turns to the left. So our plus will now be at the bottom. Our heart will be 1 space to the left of that. The arrow will be the next in the top left. Our circle in the top right. And then our square rectangle figure in our last position there. And again, we can see how they all turned as well. And that is our rotational symmetry for 2-dimensional shapes. Now let's see what happens when we bring in our other types of symmetry here when we get 3-dimensional figures. So now our next kind of symmetry has to do with reflectional when your shapes become 3D. So we have what's called the line, the plane, and the axis symmetry. So specifically, line symmetry is when a figure can be mapped onto itself by a reflection. And we've talked about reflection before. So a reflection over a line, like our x-axis, y-axis, y equals x, y equals negative x, or any other kind of line that might be drawn on our figure. We have plane symmetry, which is a reflection over a plane, and this one is more for 3-dimensional shapes. And then our last one is the axis symmetry, which says a figure can be mapped on itself by a rotation this time. Over an angle between 0 and 360 in a line that we call an axis. Just like the globe has its own axis, same idea here. We're going to have an axis that could possibly pass through a 3-dimensional shape. And if we turn that 3-dimensional shape, does it line up exactly where it started? Does it line back up to the original shape? So let's see what happens with our figures here. So example 1 on the back, draw all lines of symmetry in this figure. So we have a pentagon. So let's see how many lines I can get. So there's the first one, left side and right side line up and make a mirror image. I have a second one. So now I'm up to 2. I can do the same thing in the bottom corner. So now I have 3. Bottom left corner here, I have 4. And then our last one, I get 5 total lines of symmetry. Some figures could have more, some could have less. But again, it's how many lines can we draw through there that'll cut that shape in half. All right, let's look at our plane symmetry here for a second. So we have this moon shape. And so we have to think with a plane symmetry, can you slice through it and still keep the same shape? So with this moon figure that we have, I can in fact slide through this, slice through it horizontally. and still get the same figure from the top and from the bottom. So we have to kind of imagine if you were able to slice through this horizontally, take the top part of the moon off, the moon shape, the bottom part off, you still have identical pieces there from that slice. So that gives us one plane. All right, our last example for the axis of symmetry here. So we have a hexagon prism or hexagonal prism. The overall shape of this, find the two bases of these. In this case, it's the hexagons. So the only way I can do axis symmetry here is if the axis passed right through the center of this hexagonal prism. And again, if we spin it, again, right or left, it doesn't matter necessarily for the direction here. Whichever way we go, I can still turn. If we look at that hexagon base that we have, again, there would be my center, and it's very much like the rotational symmetry we saw for a two-dimensional shape, only now axis symmetry takes it into the 3 dimensions. Okay, guys, I hope you enjoyed learning a little bit about your different kinds of symmetry. Please don't hesitate to reach out to me if you have any questions at all. Bye, guys.